Hi, everybody. This is Mr. Folly. Oops, get rid of that and get my drawing stuff up. This is Mr. Folly, and welcome to the key on how to do your worksheet. I know this are notes we're starting with and not a worksheet, but I wanted to go over this first to help show you. So all I'm doing for this first part is looking at what the reactants are. Okay. So if it's an element, it's synthesis. If it's just one compound, it's decomposition. If it's an element and a compound, it's going to be single replacement. But watch out, that looks like combustion, okay? So combustion's mean because it is a compound and it's an element, but it has to be oxygen. And it has to have C's and H's and maybe O, okay? And then if it's a compound and it's a compound, it's our old friend double replacement. So that's it. So when you're doing this, I hope you end up with your activity series handy and your solubility rules handy. And let me get to them. So the first thing I'm doing is going to go all the way through on this and just say what type it is. Element, synthesis. Compound, double replacement. Compound, double replacement. How did I know that was a compound again? See how it's got two parts? It's got two parts, all right? Element, compound, didn't really look at element. Single replacement because it's not ch, right? This one is ch and O2. That's combustion. Element, synthesis. Element, synthesis. Look at all the sinners. Element, synthesis. Element, compound, it's not oxygen and ch. Single replacement. Compound, double replacement. Compound, element, but it's ch, so it's combustion. Oh, it's getting all moody and making me take a deep breath. So I think the hardest ones to identify is to not accidentally call this one right here when I got these single replacement. All right. It's nice when it's element, synthesis. This one's different. It's just one compound. Like this one's just one compound. Like this one's just one compound. Decomposition. All it can do is fall apart. Decomposition. I mean, that could be a lot of these. Another one, decomposition. I guess what I did was I started thinking I needed to zone in on them a bit. Compound, double replacement. Compound, double replacement. One compound. All it can do is fall apart. That's decomposition. Element, synthesis. Compound and an element, but I got CHO and oxygen. Combustion. Element, compound, single replacement. Element, compound, single replacement. I wish that one stayed single replacement, but didn't. Element, compound, single replacement. Element, compound, yeah, I've heard this before, single replacement. Element, that's synthesis. All right, so you start to get into a feel for what this would be like. You start to get through number 30. Hey, 2 left. Oh, no, there's more. Compound. You can see I kind of hit a stride here. Double. And then I probably looked and saw, you know what? I don't think I've done enough. Single replacements. Compound element, single replacement. Compound element, but it's the ch. And another ch with O. That is combustion. Combustion. What's your function? Burning up. Okay, I'm stuck. All right, and I think that is the end. Yeah. All right. So it's good that these are chunked together for a lot of them because we get to see a regular pattern here. I want to remind you that the charges come from the periodic table, +1, +2, skip a few, +3, 0, -3, -2, -1, 0. So my periodic table of charges is there. And you also should have your ion sheet memorized or nearby to learn them better. So right now there's some people in AP Chemistry taking this hoping I say the ions that they need, and I probably will. Al plus N2. So whenever I have synthesis, I just shove them together and check the charges. Aluminum is +3, periodic table. Nitrogen is -3, periodic table. My charges balance, I rejoice. So remember, the only ones I've got in my mind, I'm looking out for single replacement and double replacement, because single replacement, I have to check my activity series to see how much I'm like Little Wayne, and double replacement, I have to check for precipitate. All right, so double replacement, ooh, here's a double replacement. So focusing on the front ones and just swap-a-rooney. NH4, Cl. Notice I do not carry that 2 nor that 2. This 2 is here because nickel is +2. This 2 is here is because sulfide is -2. Well, I've got NH4 together now. That's why I don't carry those. And Cl. +1 and -1, they're equal. And what do I have left? I got nickel sulfide now. And nickel, as we said before, was +2, sulfur is -2, and we're golden. Okay, so now we got to solubility rule this. Ammonium is always soluble, so that means this is aqueous. Nickel sulfide. So when I look at my solubility rules, I know you want to see them for real. Your solubility rules, we're going to look for sulfides. Most sulfides are insoluble, and we're not looking at an exception. So that means I have a insoluble solid precipitate. Oh, look, another double replacement. Dun, dun, dun. So I get, I'm going to change the first one. So I'm going to have BaOH plus NaSO4. I'm going to check the charges. Barium's +2, hydroxide's -1. That will balance my charges. Sodium is +1, sulfide is -2. Takes 2 sodiums to balance that out. Now I need to check to see double replacement. I'm looking for precipitates. So my first question is always, is the first one plus, is it in the group 1 column? Barium is not, it's in column 2. So then I'm going to check my hydroxide rule. Hydroxides, most hydroxides are insoluble. Insoluble means it's a solid, so I'm going to call it a solid. Is sodium group 1? Of course it is. That's automatically aqueous. All right, single replacement. I've got F and I've got Cl. Remember, things of the same charge are going to try and replace each other. F and Cl. Now, the activity series for the negative ones is the periodic table. So F is above Cl. F is here. Cl is here. So it's going to happen. So I get HF. I don't know why my color changed, but it did. HF plus Cl. Check my charges. +1, -1. Check for diatomics. It's got 2. +1, -1 cancels out. All right. Combustion. CO2 plus H2O. You know what? I like that so much. I'm just going to look for all my combustions right now. I'm going to feel so good about myself. And I'm just going to write CO2 plus H2O. Burn, baby, burn. Disco Inferno. Burn, baby, burn. Here's combustion. So products of combustion besides Disco Inferno is CO2 and H2O. I remember my last few were, there we go. CO2 plus H2O. So I think what I'm going to do is I'm going to hunt a type of reaction. So that's the best part about combustion is you automatically know what the product's going to be. Let's look back up. Whee! Okay. So whatever this next one is, we'll look for all the synthesis ones. So all I do is combo and crisscross. Combo and check my charges. So it tells me lead is plus 2. Whoa. So lead is going to be plus 2, and Cl is going to be minus 1. Notice I don't take the 2, because that's because it's diatomic. So I get PbCl2. Another synthesis one right here. Smush them together. Remember, positives go in the front. Manganese goes first. It tells me it's plus 4. And iodine, negative 1. Balance those charges. MnI4. More synthesis, you say. More. You got it. Mg plus 2, F minus. Let's hope that's not our grade. Finals are coming. Balance those charges. You get MgF2. O and Ba, remember, you got to put your positive 1 first. Barium plus 2, O minus 2. Notice I don't carry subscripts. Those equal each other, and I get Bao. Single replace synthesis. Here we go. Silver plus oxygen. Silver, the tricky, crafty D block metal who's always plus 1. Oxygen's minus 2. And I have Ag2O. Whee! More synthesis. Cobalt. It tells us it's plus 3. Plus 3. It's a D block metal. Oxygen, minus 2. I said plus 3 and I wrote plus 2. So now to balance those charges, it takes 2 and a 3. Let that be all of my... Nope, I got a few more synthesis. Magnesium is plus 2 from the periodic table. I is minus 1. And remember, that 2 is because it's diatomic. We don't worry about being diatomic in a compound. Although you would have gotten it right on a good guess on this one. Okay, let's hop back up to the top. We did all our synthesis. Let's do our single replacements. So remember, single replacements are the activity series ones. So I'm going to have to keep popping back and forth in my activity series. So iron is positive, so I'm going to look at H. So let's see, is iron above H? Activity series. Iron. H. It is above, so it's going to happen. So I'm going to get FePO4 plus H, diatomic, and iron is plus 2. Phosphate is minus 3. I memorized my phosphates. It told me iron. So remember, to show that you have 2 phosphates, you need to put it in parentheses. Okay? So remember, whenever you want to show 2 of that ions, parentheses. Wow, this is a very cumulative test. Yeah, you know, it kind of is. All right, still looking for my single replacement friends. Here we go. Aluminum and Ag2SO4. Aluminum, and Ag. Aluminum is above Ag, so it's going to happen. So you get AlSO4 plus Ag. Think about diatomics. Silver is not diatomic. Aluminium is plus 3. Sulfate is minus 2. Balance those charges. They kind of crisscross themselves there. This is a 3, and I wrote the wrong number here. Al2SO4 3. Barium and gold. I do remember gold's in the bottom, so I'm not even going to look. So that means it's going to work. I get BaSO4. AP Chemistry's favorite precipitate plus gold, and gold is not part of Hunkelbrief, so it is not diatomic. Sodium and magnesium. Ooh, I wonder. Sodium is just above magnesium, so it's still going to happen. So I get NaCl plus Mg. Again, that 2 does not carry with, because that 2 is here because magnesium is plus 2. Okay, and remember, no charges. Whenever you write your compounds, you do not leave charges on it. Manganese, and aluminium. I think I don't have Min on mine. I'm going to just make this up. So, I don't need Min and aluminum. So Min should be in here. Just for kicks and grins, I'm going to put Min down here. So we will say that aluminum is above Min. So then we'll just say no reaction. No reaction, just because we haven't had one of those yet. And I picked a cheap activity series. Single replacement, HCl and zinc. Is zinc above H? Here's H. Here's zinc. Zinc is above H. So I get ZnCl plus hydrogen's diatomic. Zinc is +2, chloride is -1. Dun, 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 dun. That turns it into ZnCl2, but I can't erase the positive, and I have to. There we go. Yay, we got another one down. Another one down, and another one down. Where are we? What's up next? Ooh, it's double replacement time. Get ready with your solubility rules. I'll get ready right now. Here they are. I want to emphasize knowing that group 1 ions are soluble makes the world a happy, happy place. Okay, double replacement. I'm going to focus on the first dudes swapping places. KF, my mother's initials, and CaSO4. Potassium's +1, fluorine's -1. That's good. And calcium's +2, sulfate's -2. That's good. So we got to figure out which one is the precipitate, if there is one. Potassium is group 1. Remember, that's the first question. Anytime it's group 1, it's aqueous. Now I got to check calcium sulfate. Sulfate rule. Most sulfates are soluble. Exceptions are calcium. So that means it is a solid, and that means the reaction happens. Find me some more doubles. Find me some more doubles. All right, more doubles. Swapping those out. I'm going to have NaCl. Don't carry the 2. The 2 is there because of barium. Don't carry the 2. The 2 is there because of carbonate. Plus BaCO3. Okay, so group 1, aqueous. Carbonate, need a carbonate rule. Carbonate, carbonate, carbonate. Most carbonates are insoluble unless the above rules. Where'd it go? How did I lose my carbonate? I had it. Barium carbonate plus NaCl. We said this was aqueous because of sodium, and this is a solid because carbonates are insoluble. All right, double replacement. Got some aluminum and potassium to switchy. KSO4 plus Al-alpo4. Charges do balance here, but I need to do this to balance the charges. Sulfate's -2. I know right away that K2SO4 is soluble because this is a group 1 ion. I gotta look up phosphates though. Phosphate. Here's phosphate. Most phosphates are precipitates. There are no exceptions except for group 1s. I didn't say this out loud, but I know aluminum is not a group 1, so that's nice. Decomp. Any more doubles? Any more doubles? Any more doubles? Here's some doubles. All right. So I'm going to switcheroo copper and hydrogen. So I'm going to get CuS plus HCl. Notice I didn't carry the subscripts. Now, I need to figure out the charge on copper. So copper is a Roman metal, so I don't know its charge, except for it tells me right here. This 2 right here says, hey, copper's +2. So it's going to be the same on both sides. And sulfide is -2 from the periodic table. That's an ornery cuss. Get it? And that balances. So H is a group 1, so it's going to be aqueous. So let's take a look at sulfide rule. Most sulfides, hey, it's underlined in green. Most sulfides are insoluble. It's insoluble, which means it's a solid. NaOH and strontium chlorate. NaClO3 plus SrOH. These are both +1, so it's good as gravy, and aqueous because sodium's group 1. Strontium is +2, hydroxide's -1, so SrOH taken twice. Let's look for a hydroxide rule. Hydroxide. Most hydroxides are insoluble unless it's group 1. This is a group 2, so it means it's a solid. Insoluble means solid, man. Solid. Okay, that last page is done. I think all we have left is, let's see what we have left. I think all we have left is decomposition. So if I've got decomposition, I just have to write down my elements and look out for Hunkelbrief. So I get H plus S. Hunkelbrief, I'm done. Mercury oxide, Hg plus O. Hunkelbrief, got it. NH3, N plus H. Hun. Yeah, okay, there you go. That's so annoying. Aluminum sulfide, aluminum plus sulfur. Notice the subscripts do not carry. And Hunkelbrief doesn't have ALS in it. All right, more decomposition. Okay. Chromium plus chlorine. Hunkelbrief, no chlorine. Iron oxide, iron plus oxygen. Hunkelbrief. Hey, I'm all done. That took forever. I will see you all tomorrow where we get to do a lab. Toodles. Oops.